Okay, good. My name's Earle. This is Hilda. She's with me. We're going to describe what the kind of work we're doing on the Cape. We are basically interested in the wastewater pollution problems of the Cape and how to fix them. And we've studied the problem, and it's considered by most people that the problem that causes the water pollution is nitrogen getting into the groundwater, getting into the ponds, and getting into the estuaries. And it's too much nitrogen. It's an unnatural amount. And when you investigate, you discover that most of the nitrogen that's causing the problem is coming from the urine of people in their homes, through their flush toilets, into the septic tanks, and into the sewers, and into the ground. And then it seeps through the ground to the ocean. And this is a Cape Cod picture from a satellite. All that green that you see along the edges is algae growing on nitrogen pollution that's seeping out of the ground from all the houses on the Cape. So our town of Falmouth has the same problem. All that greenery you see is algae growing in the saltwater coast. And the ponds that you see in the picture are freshwater ponds, many of them, and they are also polluted and green. And it's all because of nitrogen that is coming from people.
Well, these are all estuaries. Falmouth has more estuaries than any other town in New England, I believe.
Mhm.
Well,
So the one thing that we'd like to try to weave in here is the climate. We are very concerned about the climate, and it is a topic that never, ever comes up when you talk about wastewater. It's like people don't equate wastewater with climate issues at all. Well, it's a big, big issue. So we'll try to focus on that as much as we can and for your group.
So the basic facts here are that one person produces 120 gallons of urine a year on average, and it contains nitrogen. It contains 8 pounds of nitrogen. And the urine from people contain 80% of the nitrogen in the wastewater coming out of your septic tanks or in the waste stream underground that pollutes the water. But that 80% of the nitrogen is only in 1% of the volume of the urine compared to all the rest of the water. So it turns out that it's the most efficient way to stop nitrogen from polluting the water is to divert that small volume of urine and take it away, use it some of the way, divert it away from the groundwater, and not put it into the ground. So most watersheds on the Cape or anywhere is a piece of land that slopes slowly to the ocean. And when it rains, the water goes into the ground and you have groundwater moving to the ocean. People build houses and they put septic tanks in the ground, and they put urine in the septic tanks, which goes down into the groundwater, which is moving slowly toward the ocean. And it moves about a foot a day through the soil towards the water, towards the sea. Now, if this water gets polluted by the nitrogen from all the urine from all the houses, it can pass through a freshwater pond. And as it passes through, it's an unnaturally high amount of nitrogen, and it causes cyanobacteria to grow, which is a toxic, poisonous bacteria, algae. And then it goes back into the ground again and onto the estuaries along the shore, and the polluted nitrogen comes out into the estuary and causes fish kills and pollution on the edges of the estuaries. So what happens here is if you're in a freshwater pond that gets polluted with nitrogen, you get
And phosphorus.
cyanobacteria growing.
And phosphorus.
And phosphorus too. Nitrogen and phosphorus both cause cyanobacteria to grow. Once the pollution gets to the coastal estuaries, it can kill fish by making algae grow too fast and decomposing and taking the oxygen out of the water, and the fish run out of oxygen. And eventually these nutrients get into the actual ocean, and they cause pollution in the ocean. All the food from all the people on the Cape goes into the groundwater. The nutrients from all those people ends up in the ocean. And it causes things like red tide, which is another version of cyanobacteria. Now, the normal solution that people go to and the towns turn to is they decide we're going to build sewers and collect the waste from the houses and treat it and try to get rid of the nitrogen out of the wastewater. And then they put all the water back in the ground again. So a sewer only does one thing. It takes some of the nitrogen out of the wastewater that goes to the sewer. It turns it into gas, nitrogen gas, puts stuff into the air, and then all the rest of the water, which contains some of the nitrogen, all the phosphorus, all of the other minerals, all the pollutants, all of this contaminants that went into the ground, into the water, go back into the ground again. So it basically only deals with nitrogen, and it wastes everything else. It does not recover any nutrients or recycle any nutrients.
Yeah, let me explain a little bit. So when people say the sewers treat, and then they say the water that comes out the effluent is as clean as drinking water, that is not true. What they mean is the amount of nitrogen left in the effluent is the same as is required as a minimum or a maximum of drinking water. So they're only talking about the nitrogen content in the effluent. And everything else, all the other pollutants, all the other minerals are still in the effluent. We do not clean the water with sewers. We only remove some of the nitrogen because you cannot get rid of minerals in nature. They just move from one place to another. So sewers, all they do is gas off nitrogen, and they move all the other contaminants and all the nutrients to another place. That could be the same watershed by putting it there, or it could go to another watershed, but it does not go away.
Okay. There are several other ways people, towns try to solve the water pollution problem. One is they make special septic tanks now, which are basically miniature sewer plants that people put in their backyards. And the waste from the house goes through these special septic systems, and some of it, the nitrogen is gassed off into the air, but all the rest of the nutrients and all the water still goes down into the ground. It costs $300 a pound of nitrogen for a central sewer to process the nitrogen in the wastewater. A person makes 8 pounds in a year, so it costs $2,400 per year for sewer system to process one person's nitrogen. There are other ways you can do this. We're going to talk about urine diversion, where you take the urine, which contains all the nitrogen, and you collect it and you make it safe to use, and you send it off to a farmer who uses it as fertilizer. And doing it that way costs only a tenth as much as a centralized sewer or as a special septic system. So it's a much cheaper solution as a way to deal with the nitrogen.
Also, yeah, at the same time, we get to the water here. At the same time, what's not included in that is the savings on water if you do waterless urine diverting toilets. And it doesn't have any of the climate issues that sewers has. We'll get into that later. So right now we can go over the amount of water that we can save. If you have a waterless urinal, just the urine is about 4,000 gallons per person per year. If you have only men doing it, then it's probably that's about 4,000, right? For feces, it's about 2,000. Altogether, it's 6,000 gallons of water that we use as a way to transport our waste away from our house into a pipe that leads to another place. So water is only used as transport. There's no other function. And the 12,000 gallons of water is now polluted with about 135 gallons of human waste per person per year. So the amount of water that we waste and pollute is a huge compared to the amount of waste that we actually have to deal with.
So, in terms of greenhouse gas emissions, our society, the way we produce food and deal with our waste water is extremely bad for greenhouse gas emissions. It starts with making fertilizer for agriculture in a big factory, and it's made with natural gas. Very high amounts of fossil fuels goes into making the fertilizer. And then the machinery and fertilizer is used to produce food. And then energy is used to transport the food to the person who eats it, often thousands of miles. The person eats the food and he puts the waste nutrients from the food they ate into the ground, either in a septic tank or to the sewer. If it goes to a sewer, the sewer produces carbon dioxide, carbon dioxide, and methane and nitrous oxide in the way it operates. And over the whole world, sewer systems produce about 7% of all the global greenhouse gases, very high amount. And then the nutrients some of them are trucked away and put in an incinerator and burned up, and they produce emissions there. And so all the way through the whole process, greenhouse gas emissions are being produced. And if you have urine diversion and recycling of the human waste nutrients, you can eliminate all of those emissions.
The weird part of this system is that we spend all the time and all those emissions on getting rid of nitrogen, which is essential for food production, that we absolutely need to then replace again with using more natural gas to make more fertilizer. So it's like a loss on every single part of the food production. So spending all that money on getting rid of nitrogen is absolutely ridiculous because you have to make it again.
So the two solutions which are normally chosen by towns at this moment are sewers, which is on the left, the great big pools of water and bacteria make the nitrogen gas off, or the special septic system, which they are going to start requiring people to put in, which are basically little sewers in your backyard where the nitrogen is gassed off. To hook up to build a sewer for a single residence costs a town about $110,000 now per house. To put in a IA septic system, the homeowner has to pay for that, and the homeowner has to pay up to $50,000 to $80,000 to put this thing in. And so both of these are very bad solutions, extremely expensive. They produce emissions, all of them, and there are better ways.
So yeah, the IA systems, they always say, oh, they cost about, on average right now, which we heard yesterday at the conference, on average it's now $48,000. But what's not included is all the landscaping. So if you have trees or decks or whatever it is, in the place where they have to put this, that is your extra cost. And to fix it later and put your landscape back again, that's another cost. Those costs are not included in any cost that you have seen mentioned anywhere.
So,
and the maintenance, they never mention the maintenance, which can be very high. The last person we talked to for her was extra $80 a month on electricity. There goes the climate. And then they had to have an engineer come. In some cases, it's monthly. Eventually, it's 4 times a year. Then it goes to 2 times a year. Then eventually, maybe once a year. And that might cost up to $400 per visit.
So what the towns typically do is they try to put sewers down at the estuary, but that's not where the problem starts. The problem starts on every house in the watershed, and by the time it gets to the estuaries, they put the sewer down there, and it doesn't fix the freshwater ponds, and it doesn't do any good for anybody upstream in the estuary. So we propose that people divert the urine from their houses with special urine diverting fixtures and make it safe to use and transport it off to agriculture. So if you do that, your uh, your groundwater becomes much cleaner. Instead of putting the urine down into the groundwater, you take it away above the ground, and the groundwater becomes cleaner and it goes through the freshwater ponds and does not pollute them from the nitrogen and does not pollute the estuaries.
Yeah, so it's a really good way to fix all the problems instead of doing only the dense areas close to the water. And the only reason they do that is the only way that you can afford a sewer. And so they fix that, and then they have a quicker result because people live closer to the problem. So they hope they can see an improvement on the estuaries quicker, because everything else takes about a foot per day to move. So that's what the reason why they do it. But it doesn't do anything for upstream, for any of the rivers, bogs, whatever is upstream. They're not going to get fixed at all. So we try to do the opposite and fix all the waters, and then that way the estuaries get fixed.
So there are several different categories of special bathroom fixtures you can have that divert the urine. One is composting toilets. There are a number of different kinds that you can have. And several of them are permitted by the state, and the urine is diverted into the compost. It isn't collected necessarily as a liquid, but it can be mixed in with the compost, but it does not go into the groundwater. There are other composting toilets, which is one here shown at the top, where the urine is diverted, it's collected and recycled, but the solid material goes into compost separately. And this was studied 10 years ago in Falmouth. And if you have composting toilets like this, it diverts 90% of the nitrogen, keeps it out of the ground, diverts 99% of the phosphorus, keeps it out of the ground. If you have urine diversion only, where you just have urine separated, you can reduce the nitrogen by about 80% and the phosphorus by 55%. So there's a difference between diverting urine just to keep it out of the ground and recycling it. If you're simply interested in keeping it out of the ground, you can have a urine diverting fixture that collects the urine and then you export it. You can put it into compost, which keeps it out of the ground, or you can, or you can have an incinerating toilet, which burns it up, but it doesn't go into the ground. Those three ways, you can just simply keep the urine out of the ground. It's diverting it. But you can also recycle the nutrients in the urine. That's called PeeCyling. That's when you collect the urine as a liquid, you store it, you treat it, you make it safe to use, and you give it back to agriculture. So where do the nutrients in the urine come from in the first place? It turns out that it comes from the food you eat. 460 million pounds of food are trucked onto the Cape every year. And all the nutrients in all that food goes into the groundwater through the toilet systems, and virtually all of it ends up in the wastewater and in the ocean. Over the entire world, virtually all the food, nutrients and all the food that people eat ends up in the ocean. Very little of it is recycled back to agriculture where it started, where it came from. Also on the Cape, one of the causes of pollution in the water is fertilizer, normal industrial, commercial, chemical fertilizer people buy and put on their lawns or on their ornamentals. And the Cape imports 6 million pounds of fertilizer, and that becomes part of the pollution in the water bodies. So those two things together pollute the groundwater. One of the details of this urine diversion idea is you can use the nutrients in the urine as fertilizer to replace a lot of this chemical fertilizer, which is imported over the bridge. So you reduce the total amount of nitrogen that's coming in to the Cape. So the ways you could immediately fix the water pollution is to allow people to have a wide range of urine diverting fixtures in their homes if they want, and start to separate the urine out and collect it and send it to a farmer. and you need infrastructure to do that. You need fixtures in the homes, and you need on a town level, a community level, a system to collect it and truck it away, treat it, and send it to the farmers. And you need incentives for people to do this. Many people would do it on their own. They'd pay for it themselves because of the ecological benefits. But on a town scale, it would help to have incentives where you use some of the money you would otherwise spend on sewers, millions, if not billions of dollars, and subsidize people to do this instead because it's ecologically better and cheaper. So what are some of these urine diverting fixtures that you could use? There are two different groups. One is fixtures that simply divert the urine as a liquid, and they range from really simple, portable, cheap, unisex urinals, which are developed by the Rich Earth Institute, which is a research institute, a nonprofit in Vermont, who does research on urine diversion. They invented these things called cubies. They're little portable urinals used by men and women, and you can divert urine that way. We're working on a urinal that fits into the wall of a bathroom for men, and it's an in-wall urinal, waterless, and it's used in the home. Typically, men use urinals wherever they go in society and any public building, but not in their homes because people don't want the traditional big ceramic white urinal in their bathroom. But this is a way you could have a urinal in a bathroom, which men prefer, but it wouldn't take up a lot of room and would be pretty non-obtrusive. There are urine diverting sit-down toilets where people can use, which only are used for urine, and it's stored in containers, and they're made commercially in Europe. And there are simple ones that are made by the Rich Earth Institute. There's also a urine diverting flush toilet where the urine is diverted, but otherwise it acts like a normal flush toilet and the solid material goes to your septic tank. And then there are composting toilets, a great range of them. We won't go into it, but in most cases they make compost and the urine ends up in the compost or it's diverted separately from the compost. So what do you do with this urine? If you divert the urine from your house, say from an in-wall urinal in the bathroom, you have it go out of the house in the pipe into a tank buried in the ground, or you have it go into a tank in the basement. In Vermont, they do both of these. They do it also in the basement. They do both of these things. So the picture in the middle shows a urine diverting flush toilet where the urine goes to a tank in one direction and it flushes the solids off in another direction to your septic tank. And if they have a in-wall urinal, it can also go to the same tank and buried in the ground outside. And then what happens, you can store it other ways. You can store it in containers. And in the Rich Earth Institute, they collect it from people and they put it in, they sterilize it and they put it in large containers and they sell it to farmers. In Europe, there's a company that collects urine and they store it in these big cubicle containers and they process it and they make it into fertilizer for farmers. On a home scale, it is safe to use urinal directly in your own landscape from your own home if you carefully put it on the ground at a proper rate on the soil around the vegetables, around a tree, around a flower bed, around a shrub, and it's a high quality fertilizer. On a commercial scale or on a town scale, the Rich Earth Institute has developed a machine that will pasteurize and make the urine safe to use. And what it does is it passes it through this thing and it heats it up for 176 degrees for 90 seconds. And that's enough heat to kill all the pathogens and all the viruses. So what they do is collect the urine in Vermont and they pasteurize it, and then it's become safe to use as fertilizer, and they give that off and they give that to a farmer. And the farmers in Vermont use it on hay fields and in cornfields as another fertilizer instead of commercial fertilizer. We would like to see another option on a community scale, town scale, where you have a composting device where you put the urine in with leaves and landscape debris and food waste, and you make compost with it. And if you sterilize it and pasteurize the urine first, it's safe material, and it becomes a solid compost fertilizer, which can be used the way that commercial compost is used.
So this is another one of the climate issues, because we know that landfills could contribute to climate and to greenhouse gas emissions, and food waste is one of the major ones on landfills that do that. So there's now a big push to get the food waste away from landfills and do something, compost it, use it, and reclaim it again as an amendment. They're struggling with it. Most of the waste, food waste, is done on composting in rows and big piles outside. A lot of the nutrients go in the ground, and it's not an ideal way to process it. So we would like to see it happen in a container that's closed, that is monitored, that has a computer attached to it with sensors inside, and they know exactly how many days it has been on a certain degree, so that they know it's composted safely. And then it can be, it falls out on the other side, and it can be compost bagged up, and it's more stable and easier to store than big volumes of urine. So that's what we would like to see on a community scale. Falmouth has piles and piles and piles of leaves. We have lots of wood chips, and all those things are just sitting on the ground, not being used and actually contributing to pollution. So we would like to see that combined with urine. Hasn't been done yet. The combination would be fantastic, but we have to go through all the regulations to get that off the ground. But that would be an ideal way to recycle our nutrients from urine and keep it out of the ground, and not need any sewers or IAs.
So these are the three ways that a community or a town could do urine diversion and recycle it. You could take it to a sewer and put it in the sewer, and they would treat it like normal wastewater, but you'd lose all the nitrogen. That's a kind of a wasted way to do it. You could have it pasteurized with a pasteurizing machine and truck it off to farmers. And I propose that you take it off the Cape and you give it to farmers over the bridge where they have more agricultural land, and they distribute it on the land. It takes 1 acre for 10 people to distribute a year's worth of urine. So a city of 30,000 like Falmouth needs 3,000 acres somewhere over the bridge to process a year's worth of urine. So it's within the range of feasibility to recycle the nutrients from the food people eat on the Cape over the bridge to farms over the bridge. And you eliminate the worry about putting it back in the ground on the Cape.
It's 10 people per acre.
10 people per acre. And the eco drum or the composting drum option, we would like towns to do also, because there are many advantages to that. And it would also be economically a viable thing to do.
So look at the cost to make a urine depot with a pasteurizer is about $24,000. That one pasteurizer can probably handle about 180 people. So again, the cost compared to sewers is very, very, very little. If it was one hookup of a person is now $110,000, having this several of this in the community is really nothing compared to what we are proposing. Transporting, it costs about 1 penny per gallon of urine to be processed and treated and make it safe for agriculture. So that's about $1.20 per person to treat per year to treat the urine and make it available for agriculture. To transport it, we figured, well, let's do 70 miles, because right now in Falmouth, we transport our sludge 70 miles away from Falmouth, from the sewer plant. It goes to an incinerator in Rhode Island. It gets incinerated, becomes toxic ashes. If you do it at home and you incinerate it in your home incinerating toilet, it's not toxic. But when you combine it with all the other contaminants, it becomes toxic waste. And after that goes through, becomes toxic ashes, it has to go to a toxic landfill. And we know where the incinerator is, but they will not tell us where the toxic landfill is. That has been kept, that's information we cannot get right now. And we hope to get it eventually, because it should be public knowledge where our waste actually ends up. And then once it's in a toxic landfill, then it seeps into the groundwater and goes back to the ocean. So none of these minerals or contaminants ever disappear. They just go to another community, another place.
So in general, urine diversion, the infrastructure, the technology required to do it is all proven, it's available, it's low tech, it's reliable, it's adaptable, it's flexible, it's environmentally more beneficial than other solutions, it's affordable, it's much cheaper, it's like a tenth the cost of any of the sewers or these special septic tanks. And it's less costly to the towns or to the taxpayer.
So one thing that's not there is the greenhouse gases. And we bring this up all the time because it's contributing so much to greenhouse gases. And it's all a waste. So we waste all the nutrients, all the electricity, and then we pollute our climate. So when we ask them, so what is the carbon footprint of a sewer? Well, they don't know. They've never had to measure. A mass DEP does not require a sewer plant to put that into the plant. So if we try to get to net zero at some point, we'll never get there because there's certain areas that are not included. So if you have all these sewers and all these sewer expansions, those numbers of extra greenhouse gases are not included in any of the calculations. So we'll never get to that net zero. That's why right now, as we all know, it goes up and up and up and up, no matter how hard we try. And the same thing is with IA systems. IA systems do the same thing. They contribute to CO2, methane, and nitrous oxide. We don't have a slide on that, but we would like to introduce that as well because, again, we had a meeting for the Cape yesterday, a whole day conference, and climate change never ever comes up. The waste of nutrients never comes up. So these are externalities that have to be included if we make decisions of such major town. It's like the biggest cost that the town can do, but it's also the biggest contributor to our climate. And if that doesn't get addressed, then I think it's an unsustainable solution.
So in order to do this on a town scale or a Cape scale, we would propose that the town subsidize some of the fixtures in homes. They give grants and loans for people to install them because it would be environmentally better and cheaper for the town in general. We also would like the towns to say, if you have urine diversion and you can show that you've diverted 80% of your nitrogen this way, you do not have to hook up to a sewer if the sewer happens to be built near you, or the IAs happen to be required in your area, because you are not contributing to the problem, and you should be exempt from that. So we would like towns to have these two incentives for people to do this.
So yeah, remember that it costs $110,000 per house. So, and that does not include the maintenance of a sewer, the sewer fees and all that. So for a town, if it costs $2,400 to take 8 pounds of nitrogen away, they can spend that on giving people incentives because then it becomes much more efficient. So that's what we're proposing. And we said, if we have a pilot project in Falmouth, you should not only help people pay for the installation, you should even give them money for every single pound of nitrogen that they have removed, that the sewer doesn't have to remove or some other IA system doesn't have to remove.
Let's do the last one. You do that. This is.
Yeah, so we went through this already, that it conserves water, which never comes up as an issue, which becomes more and more critical, even in Falmouth and even on the Cape, because it costs more and more to clean our water. As an example, as we all know, like in my home country of Holland, it's all water. I mean, we're not lacking water there, but we're lacking clean water. And to clean the water, it becomes more and more expensive because there's no clean water to start with, because all the water is polluted. We're getting the same thing in Falmouth or on the Cape. The water gets more and more polluted, costs more to process it, to make it into clean water. So in Holland, they asked people to reduce their water use only for the cost of making it into clean water. But then they flush most of the water in the toilet. And that's that drinking water that they made to drinkable water to flush in a toilet and waste. So, and that's the modern way to do it. And the whole world tries to copy that, and it's going to be an incredible disaster. So this is all the things that we talked about. If you conserve, if you divert urine, you conserve water, you make fertilizer, you have fewer greenhouse gases, and it's extremely low tech and extremely reliable, which none of the other systems are.
So that's the basic idea. So we've been working on this for the last 15 years, and we educate our town and we try to educate the Cape. Other towns, people are very interested in it. The most interest comes from people who live on freshwater ponds, which are getting polluted with toxic water, dangerous water. Their property values are going down because no one wants to live near a toxic pond. So they see this as a possible way for them to clean up their ponds.
So is there still time for questions? And
I think we could have a couple questions, and this is just amazing and probably deserves another look at another time. But I guess I'd like to say, Steve, I see you have your hand up.
You're muted.
Did you say there was a pilot project now in Falmouth? Or you just hope to have a pilot project?
about our pilot.
Okay. We did a pilot project.
The Green Center did.
Our nonprofit Green Center last fall did a pilot project because we got tired of waiting for our town to do one. So we had people voluntarily use cubies, 60 people, for 2 months to collect their urine and store it. And then we had it measured and tested. And we just found out how, by the Maztec County Agency, and we figured out how much nitrogen people could divert with extremely simple, cheap, affordable methods. If they did that for a year, it turns out that they could divert as much nitrogen from their house that way as you would divert with a sewer if you did it for like almost no cost. So we did that, and that was the first time it had ever been done in the world. No one had any of these numbers before, and we are hoping the Mass DEP state agencies use this to help promote this technology. We are trying to get the town of Falmouth to do a big study for 3 years for 50 homes and have the Mass DEP judge it at the end of that time of whether it is equal to or equivalent to these special septic tanks. And if so, give the towns credit for removing nitrogen in their wastewater plans, their what do you call them, watershed plans, as one more way to process and treat the nitrogen. And we want to give credit for this technology to the town. And so we're trying to get the town to commit money to do this 3-year project, and it will come to our town meeting either in the fall or next spring to pay for it.
How did the residents accept the these urine collectors?
Oh, they love them. Actually, people really enjoy having them. Actually, everyone who used them during this 2 months are still using them, and they use them voluntarily, preferably, instead of their normal toilets, because they do it for environmental reasons. They're willing to change their habits and invest some money to fix these water pollution problems voluntarily.
Well, another good thing is, because it's a urinal, men are used to urinals. It works much better for a man. It works much better for the women, because the men, when they use flush toilets and water toilets, it always makes a mess, and that cannot be avoided. So the women are very happy because the men don't do that anymore, and the men are happier because they are used to urinals. And then you can collect it in that container, and you can bring it straight to your garden or to the forest or wherever you want to, and put the urine there. So people have really liked it, both men and women. And this particular urinal is also works great for women. It's not a problem at all. So yeah, both women and men can use it.
There's one other
So-
new, go ahead.
So I know you have given periodic tours of your operation in Falmouth. And if anyone who's on this call wanted to follow up and come see what you're doing, or perhaps get someone from their town to come with them, what would be how would we do that?
The best way for us, have we found out over the years, is if you organize your own group.
Mhm,
We can go up to 15 people, but not more than that. And
mhm.
then we set a date that works for you and it works for us.
Okay,
And that is the easiest, because if I set a date and put it in a newspaper, it's
Right.
really hard to find out who's
Mhm.
coming, how many people,
yep.
and it takes a lot of organization, basically. So that's what we kind of prefer to do. And we
Okay.
are pretty flexible. So come up with, 10, 15 people, and we just make sure that we can arrange for a tour at your best time.
So I think that would be, I know that there have been some people I've been talking to in Plymouth, not in this meeting here, but others that are interested in coming to see your operations. So I'm sorry that we are about out of time for this presentation, but I just think it's wonderful. And I never really I never quite had focused in on the climate, the greenhouse gas emissions involved in processing
Yeah,
the waste. So that is really important.
I
And
think that sewer plants in a town, and on average in the country or everywhere, is the highest cost of a town operation and the highest greenhouse gas producing entity. So that's two bad things. And we have actually an article about that one that we can send to you about that we wrote for the newspaper.
that's
Oh,
This-
great.
it's just great. And I have this recorded, so